Welcome to the 8th video in this video series of using Godot with C# and the Writer IDE to dynamically modify a 3D mesh. In our last video, we displayed the surface normals, the face normals of the cube, and then we enabled exported variables on the main script to allow us to toggle on and off the different features, the axes, the face normals, and the wireframe. In this video, what we're going to do is we're going to actually generate this green cube again. If you remember at the very beginning of this video series, what we ended up doing is we exported a cube out of Blender, and we exported it out as an OBJ and called it mycube.obj, and then we created a mesh instance, and then we assigned an array mesh to this mycube.obj. So this was all just a Blender export. But what we want to do is we want to actually generate the mesh in code ourselves. And if you remember, because after we get rid of this, we're going to have to reset this all back up again. But after we set up the cube, then what we did is we went to the mesh menu here, and then we created a collision object for it. And then on the static body itself, we assign some signals to go to certain callback methods. And we're going to have to handle that all ourselves now in code because these aren't going to be here. So let's go ahead and start the scary thing here. So what we're going to do is we're going to go to the cube, and we're just going to set it up as we're going to go ahead and clear it. And once we clear it, you're going to notice the green cube is going to disappear here. It's still got the static body and collision shape, so what we're going to do is highlight the static body, and then we're going to delete that. And now everything's gone here. So we're going to have to do this all ourselves. So what we're going to end up using here is we're going to end up using the surface tool. And the surface tool, there's a lot of things we can do with the surface tool. For our purposes, since we already have a cube mesh instance and we're going to assign a material on that, I don't think we need to worry about the vertex coloring here. And we're not going to worry about the UVs right now because we're not doing any texturing per se. So I honestly think the only thing we need to worry about is just adding vertexes and then computing the surface, the face normals after we're done. So this actually should be pretty straightforward, but the hardest part is going to be actually defining the points to make up the cube. So if we go to Writer, what we're going to do here, if you remember our ready method from when we refactored it the last video, we've got a bunch of things here that we're doing. And what we'll want to do here is we'll want to have a method, and we'll want to have a method called like create cube mesh. And actually we're going to call it create and assign cube mesh, because after we create it, we're going to assign it to that cube mesh instance. So we have that set up. Private void. And then in here, we'll make this the very first thing that we do. Obviously, this doesn't do anything yet. Oops, doesn't do anything yet, but I wanted the and to be capitalized. All right. Okay. So what we want to do here is we first want to define the cube, the cube's structure. And we're most likely going to want to, the easiest way to do that would be to use an array to do that. So what we're going to do is let's go ahead and create a placeholder here. And we'll say unique cube vertices. Let's call it that. Don't want that. Okay, so inside here, we're going to want to set up these list of vertices that make up the cube. Well, now we have to start thinking about, well, what does it mean? Like, how are we going to assign those? So you got to kind of have to think about what makes up a cube here. So I drew this little diagram here. Obviously, the red, green, and blue lines are the x, y, and z axes. And then the cube itself is made up of 8 different points, 8 different vertices here, right? And then we connect edges between them. And so for this front face, we would want to connect 2 triangles, because there would be a line diagonal going here. So we'd want like 0, 1, 2 to be one triangle, and perhaps 0, 2, 3 being the bottom triangle. And as you saw there, I was listing these in clockwise order. And I found out with Godot that Godot by default will only show what it considers to be the front of a mesh. And then the question is, well, how is Godot determining what the front of a mesh is? And it depends on how these vertices are listed in the data structure. And this listed in the data structure, this is called the winding of vertices, like when you're winding a watch. So the winding, you can have clockwise or counterclockwise. So we could go 0, 1, 2 here, or we could go 0, 2, 1, because that would be a counterclockwise rotation, winding, excuse me. So let's go ahead and define the top triangle, and then we'll go ahead and assign it, and then we'll go into Godot and we'll see what it looks like, and then we'll work from there. I think if we incrementally build this up, it won't be so difficult to understand. So we're going to build this top triangle, which for our purposes, since we're going to do the clockwise winding, is going to be 0, 1, 2. And again, that's this top triangle on the front face. So what is the coordinates of 0 here? Well, it depends how wide the cube is. And I'm going to make this so that the cube's entire width here is going to be 1. So that means that from one side to the origin is going to be half of 1, which is 0.5. So the extent of all of these points at max is going to be 0.5. So the 0 point here should be, in the x direction, it should be negative 0.5. And then the y is going to be 0.5. And the z, which is kind of hard on a 2D picture to kind of visualize it, but it's going to be 0.5 out z. So it's going to be negative 0.5x, 0.5y, and then positive 0.5z. So if we go to writer, we want to actually define that first point. So what we would do here is we would do a new vector 3, and we decided it was going to be a negative 0.5x, don't want strings there, negative 0.5x, and then we'd want a 0.5y, and we want a 0.5z. Okay. I think these need to be floats. Yep. Okay. And then, so that's the 0th point. So then what would 1 be? Well, we have to go back to that diagram. So 1 here would be 0.5x, 0.5y, 0.5z. So that one's going to be easy. Everything's positive here. So if we go back to Godot, not Godot, go back to writer, we would make sure all these are positive, and they are here. So that's the second point in that triangle. And then we'd have the last one, which is the third in that triangle. And we go back to our diagram. So we're doing 0, 1, 2. Well, what is 2 here? Well, 2 is positive 0.5x, it's negative 0.5y, and it's positive 0.5z. So it's going to be positive, negative, positive. So let's go back to writer. Positive, negative, positive. Okay, so that's the first triangle. And in fact, let's just leave it there. We'll just have the first triangle. So we've got those things defined. So now what we want to do is we want to use the surface tool to create a mesh out of those three. So what we would do is we would create a new surface tool. And then what we would do then after that is we have to tell it what, kind of like when we were drawing the, using the immediate geometry and we were drawing with that, you have to tell it what mode it's in. So what we would do here is you would do surface tool and you would begin it, and then you would tell it what mode it's in. And let's see if this is smart enough to, it is. So we're going to put it in triangle mode because what we're listing here are a bunch of triangles. So then what we want to do after that is we want to actually assign, we want to add the vertices to the surface tool. So we could go ahead and just create a for loop here, but we'll do a different for loop. We'll do a for each. This will be easier to use than the normal for ones we use, because the for each we don't have to index the actual thing in the array. It just knows how to iterate through the data structure. So what we're saying is each element in that array that we define, this unique cube vertices array, we want to get out something, we're going to call it vector, and it's going to be, oops, from the unique cube vertices. So if you haven't seen a for each before, this isn't, we've been using for loops in general. Let's go, I think it's down here. So normally what we would do is we would do a for loop and we would initialize a starting point, a test condition, and then how we're going to increment in the loop, and then we would address things inside an array using the index. But in this case, we don't need to do that. We just want to iterate through all of them, and we don't have to do anything special as far as going +1 or +2. So we could do this with a for loop and then do unique cube vectors I in here, but for something like this, that's what this for each loop is kind of meant for, is for doing simple stuff like here. Because basically for each vector in that unique cube vertices, we just want to add the vertex. So we're just going to go ahead and add that, and we're going to add that to the surface tool. And again, oops, this variable here is the variable defined up here. In fact, when I highlighted it, it highlights it there because writer knows. So it's just a nice convenience way of addressing something and iterating through a data structure like we're doing here with the array. So after we have this done, so basically this code here is going to populate the surface tool with everything we've defined in the unique cube vertices, which right now there's just these three. So what we're looking to do here now is we're looking to the surface tool, when we're done, we need to make sure it auto-generates the normals for us. I mean, we could define what a normal is for this surface, but we're going to let the surface tool do the math for us. So what we would do is we would call the surface tool and invoke the generate normals, and so that will generate the normals for us. And then after that, what we want to do here is we want to if you remember, let's go back to Godot here. So if you remember in the cube here, we had this mesh set to this mycube.obj. And so in code, we want to basically do the same thing. We want to set this cube mesh instance, and we want to assign it this, not mycube.obj, but the thing we're generating dynamically. So we're doing basically the same thing. We're assigning the mesh, but instead of one of these things, we're assigning our own custom thing. So we're going to need to address the cube mesh instance. And so let's borrow that from here, because we're doing that anyway. So what we would do is we would get a handle for the cube mesh instance. And then what we would do is we would, well, let's do this in two pieces. So let's go ahead and say that the mesh we want to add, we'll call it our mesh. we need that surface tool to give us that our mesh. So what you would do is you would invoke the surface tool and you would invoke the commit method on that, and that returns a mesh. And then what we can do then is we can do a cube mesh instance dot, and then we can say mesh equals, and it equals what? Well, it equals our mesh. So this isn't going to have any of our material on it. Remember, let's go back to Godot. So if you remember, the cube, not only did it have a mesh, but we had this cube spatial material, this green material applied to it. And when we apply this mesh in code right now, it's not going to have that material. But that's okay. Let's not apply a material for now. And then after we look at the triangle that we're generating, we'll apply the material so that we're at least back to where we were. So if we go back to writer here, I believe everything here is as we need it. So let's go ahead and fire up the game, and hopefully we see something here, a triangle. And we do. So if we scoot in here, you see how we've got the upper triangle here, which was points 0, 1, and 2. And again, if we look at our diagram that we had, 0, 1, 2, that's that upper triangle. So when I was talking about this clockwise versus counterclockwise ordering, the question is, well, why does that matter? And the reason that matters is because if you let's restart the game. If you scoot around the back of this triangle, because we can rotate, remember, because of our... Now watch this triangle as we rotate. See, we can see this gray triangle, but notice how when we get behind it, it disappears. Well, that's because Godot is determining that if you give it a clockwise rotation, or a clockwise winding, excuse me, if you rotate around the mesh, if you enumerate the mesh in a clockwise fashion, it assumes that that's the front of the mesh. So that's why we had to list them as this point, and this point. So this is pretty close to what we had before, at least for the front face, but you notice it's gray and not green. So let's apply our nice green well, maybe not nice, but our loud green material, apply that to the triangle. So at least we're back to where we were with the cube as far as the way it looks. So if we go back to writer, before we do that, let's remember that the material we're applying is this green one here called cube spatial material.tres. So that's important to remember. So what we're going to want to do here is, if we go back to writer, so what we're going to want to do here is we're going to create a new spatial material. In our previous videos, what we would do is we would just create a brand new one. And that's not what we want here, because we want the material that green thing is that we made that was sitting in our game that we created. So we're going to want to make a different call here. We're going to want to make a load. And I believe here, let's go back. I think there's a shortcut we can do here without having to know this whole thing. If we highlight the thing we care about, in this case it's the spatial material, and we right click, I believe we can get if we use copy path, we can get the full path to that, which in this case is not that long of a path, but any little bit of typing helps. So if we paste that in there, we get the path to our cube spatial material, and that's what we want. Now, however, it's going to complain here because it doesn't know when it's loading, it's just loading a resource. So we have to actually cast it into a spatial material. Okay, so now we have that spatial material. And so what we want to do is we want to have that cube mesh instance. We want to set the material on that. So we've done this before. So we want to do a material override. We've done something similar to this, I should say, with materials. And we just want to set it to this spatial material. So hopefully that makes sense there. This cube mesh instance is, let's go back to Godot, is this thing right here, this cube mesh instance. So what we're doing in the first piece is we're assigning the mesh to be that triangle we generated. We're doing this in code, obviously. And then the second thing is we're going to assign this green material to that dynamic mesh that we made. So that's what we're doing here by loading the spatial material off of the drive, and then we're putting it into a variable here, and then we're saying the cube mesh instance material override is that spatial material. So if we run this game in Godot now, we should have our triangle, but instead of being red, it's going to be that green thing that we were used to saying. So let's go ahead and run this and make sure it works. And it is. So the good news here is, again, go behind it, it's gone. We've got the coloring, the material right, and we've got the front of the material set up. Now, here's something we could do. Remember I mentioned here how if you rotate around, you can't see the back of it? Well, why is that? I mean, just because it cares about the front and the back, why can't I see the back? Well, for efficiency reasons, it's better if the 3D engine doesn't render things it doesn't care about. And normally you wouldn't care about the back of something. But there might be times where you would want to do that. And, well, what would you set so that it does that? Well, it's a material property that you would do. So if we actually open up our cube mesh spatial material, I'm trying to remember where it is. So the cull mode. So the cull mode, culling something says, what am I not going to show? So right now it says I'm not going to show the back. That's the default. Well, I could tell it to not show the front. So if I do that, the expectation would be as we run the game, we won't see anything. We don't, but as we rotate around, see how we see the back of the triangle? So there might be times when you would want that. I don't know why I would use that, but there might be times. Or you might say, look, I want to see the entire thing. So what you could do is you could disable the culling, which means it's going to show the front and the back. So if we do that, you'll see the triangle is here, and then if I rotate around it, you're still seeing it. So it's a material property in Godot that determines what it's going to cull. I'm going to go with Godot's recommendation of, for efficiency's sake, let's put it back to default, which is this little reset circle. So it's going to cull the back. So just so we verify that it's still doing that. So there was a front we can see. We can't see the back. Okay, that's exactly what we want. So I guess to reinforce this one last time, so if we would have defined that triangle, instead of doing 0 first, 1 first, 2 first, if we would have done, let's say, 2, 1, 0, so went counterclockwise, this would be considered the back of the face. So we'd have to rotate around what we would consider the back to be the front. So I hope that makes sense. When you're winding meshes, you have to determine what the engine says is the front. And if the engine says, look, in Godot's case, it's saying, look, if the vertices are listed in a a clockwise motion, that's the front. And if they're listed in a counterclockwise motion, that's the back. Well, it doesn't see that necessarily as the back, but it's not the front, let's say. So I'm hoping this makes sense because this is extremely important to know which is front, which is back. This also, setting these up takes a lot of imagination to get all these points set up correctly. So let's go back to Writer, and what we're going to do instead of setting up the actual triangles, we're going to just list all 8 points. So there's 0 through 7 points, right? So we've already listed 0, 1, and 2. So let's list the third point, and let's do these these last ones, and then we'll redefine the faces a slightly different way. So 3 here would be negative, negative, positive. So it's negative x, negative y, positive z. So if we go back to writer, we go back up to where we were defining these, and so it was a, put a comma there. So it was a negative x, negative y, positive z. All right, so this is 0 point, 1 point, 2 point, 3 point. And 0, 1, 2, 3. Now we want to list 4, 5, 6, 7. So right now we're just listing points. We're not doing any triangle creation. I know previously when I did this originally, we were just trying to get the original triangle up. All we're using now here, let's just comment this stuff out because this stuff isn't quite... We're not doing the same thing now. All we're doing here is we're listing all the points in the cube. We're not listing the triangles yet. We're going to do something else for that. So we've done 0, 1, 2, and 3. So what we want to do now is let's do 4, 5, 6, and 7. So let's look at 4. So 4, that's going to be negative x, positive y, negative z. I mean, 0, 0, which is the x, the origin here, it's in the middle. It's in the center of the cube, or at least it's supposed to be in the center of the cube. I don't know if my drawing necessarily shows that, but that should be the center. So 4 is behind that. So this is going to be negative, positive, negative. So if we go back to writer, it's going to be negative, positive, negative. And then let's go and look at what vertice 5 is. That's going to be positive, positive, negative. Positive x, positive y, negative z. So positive, positive, negative. So positive, positive, negative. All right, let's look at the next one. So the next one is 6, and that's going to be negative or positive. So it's positive x, negative y, negative z. So positive, negative, negative. So positive, negative, negative. And then the final point, let's look at our little chart here, which is 7. So that's going to be negative x, negative y, negative z. So 7 is all negatives. Okay, so this unique cube vertices, what we're using this for now is we're not defining triangles here. In our first, when we first put this up to display the first triangle, we were just listing the first 3 points and doing a triangle just trivially. But now what we want this array of vectors to do is to list just all the unique vertices. And then we're going to define the faces here now. So what we're probably going to want to do here is, I mean, we could list them all in one big thing, but I'll get confused. So I like doing things very verbosely. So let's just do this. So vector 3, we're going to call this the front face. So the front face consists of two triangles. I'll go back to the diagram here in a minute. Okay. So the front face, so we already did the 0, 1, and 2. So let's redo that again, but now we can define that a little bit more routinely here. So remember, 0, 1, 2 is how we define that upper right triangle. So what we can do here is we can say unique cube vertices 0, unique cube vertices 1, unique cube vertices 2. Oops, we want a vector 3 array. There we go. So 0, 1, and 2. The good news is because we're listing them here, now we can just grab the same indice that's listed on our chart here. So it makes it really simple. See, 0, 1, 2. So then what's the other triangle here? Well, oh, by the way, it doesn't have to start at the same spot. This triangle 2, the 0, 1, 2 triangle, we could list it as 2, 0, 1 or 1, 2, 0. As long as we go in a clockwise ordering, it doesn't matter where we start. So for the bottom triangle, we can start anywhere we want, but why not start at the 0 again? So this bottom triangle, again, there's a triangle, there's a line here, 0, 2, 3, right? That would be the bottom triangle, 0, 2, 3. So let's go to writer, and let's list 0, 2, 3. 0, 2, 3. Okay, so that's the front face. Let's go ahead and just display that front face. It should be a square now versus a triangle. Let's uncomment this stuff. So we're not going to do for each vector and unique cube vertices. We're going to do in front face. And everything else should be the same here. So let's go ahead and run this in Godot. And what we should see is instead of a triangle, we should see a square now because we implemented the top triangle and the bottom triangle. And we did. And again, just reinforce. We scooter on the back. It disappears because that's the back face. So the reason I keep reinforcing the making sure the back is disappears is because the winding of these vertices, this can get you into trouble very quickly if you don't pay attention to what you're doing. If you do it wrong, you'll notice that vertices appear backwards. In fact, I think there's value in doing that. So the bottom triangle, instead of doing 0, 2, 3, which would be clockwise, let's do 0, 3, 2, which is listing them in counterclockwise order, right? So let's do 0, 3, 2. So 0, 3, 2. And let's go ahead and run the game. And what you'll notice, or hopefully you can guess what you're going to see here, is the top triangle should appear and the bottom triangle should not be there. And it's not. But if you rotate around, see, now this, because we listed it the other way, this is the front and the top triangle disappears. Hopefully you can see what's happening there. So that's why it's super important. Like if you're defining these yourself and you notice there's like pieces missing, most likely you didn't wind the vertices in the correct order. So let's go ahead and put this back the way it was. Just because I don't trust anything, including myself, let's make sure that we're back to our square. We are. Fantastic. Okay, so we got the front face. So let's go back to our picture. So what we have to define is all the faces of this cube. So we have the front face, which is the thing we defined. Then there's the bottom face. Then there's the top face. Then there's the left face. Then there's the right face. So there should be 6 faces that we're defining here. And we're going to use these same 8 points to define all 6 faces. Now remember, each face has 2 triangles in it, so we have to define each triangle separately. There's a top triangle and a bottom triangle. And the front face with this diagram is really easy because we're facing it, so doing a clockwise thing makes sense. If you try to define this back face with this diagram and you said, oh, well, 4, 5, 7, that's a triangle, right? It is, but it's going to be counterclockwise. Well, what do you mean? 4, 5, 7 is clockwise. Well, right, but you're defining it for what's the front. If you did 4, 5, 7 in this direction, it would only be the front if you whipped around the other side of the cube. So it would have to be 4, 7, 5, which from the front looks like it's counterclockwise, but when you're looking at it from the outside, like behind the cube looking at it, that's clockwise. So I'm hoping that makes sense because you have to kind of use your imagination here. So for instance here, you would do 1, 2, 6, which would be a counterclockwise. You wouldn't want that. You would want 1, 5, 6 for the top triangle here. You have to look at the face you're defining as if you're looking at it like you turned it so it's facing you, so it's the front face. And then you have to make sure the vertices that you're winding are wound as you're looking at it in a clockwise winding. And like that can get tricky. So like again, if you look at this left face, the way this drawing's going, You would think 0, 4, 7 would be clockwise, but it's not, because we're defining it from like looking outside the cube. You have to imagine you're sitting over here. And if you did that, well, you would want to do 4, 0, 7, because from that point of view, that's a clockwise rotation. I know that sounds difficult. I mean, honestly, if you had like a set of a die from like a board game, and if you just like put a little marker on each one of those corners, and then you just turn the face you were defining so it's always facing you, and then doing a clockwise, that would be very beneficial, so that you wouldn't have to try to imagine what it would be like looking at it from when you're looking at it from the front. So again, hopefully that makes sense, because if you define it wrong and you start moving around your cube and you see pieces missing, it's most likely because you wound the vertices in the wrong direction. It needs to be a clockwise rotation, not a counterclockwise rotation. And I guess I'm assuming something here. I'm assuming what the viewer knows clockwise versus counterclockwise. And I'm saying that not to be insulting, but I do notice that some of the younger generation, they're not used to seeing analog clocks, so they've only used digital clocks. So the term clockwise and counterclockwise doesn't mean much to them. And then, you know, sometimes I've tried to explain to people who are used to like tightening bolts on a piece of machinery, a bolt and a nut. You know, I'd say, well, you know, turn that clockwise or counterclockwise, and they'd go, oh, you know, was it righty-tighty, lefty-loosey? I mean, they didn't quite understand the concept of clockwise versus counterclockwise, but they still knew how to, you know, tighten up something. It was just righty-tighty, lefty-loosey. Well, righty-tighty would be clockwise, 0, 1, 2, so you're kind of moving in the right, and, you know, 0, 3, 2 would be, you know, lefty-loosey. So hopefully you've all seen the clocks, the old analog clocks where you have the hour hand and the minute hand, because that's where this terminology comes from. And I just wanted to be careful to, if this is insulting to somebody listening to this and it's like, dude, I know what clockwise and counterclockwise is, fantastic. I just don't want to assume that the viewer has that knowledge. So clockwise is this direction, which is how a clock would, those old analog clocks would turn in that direction. And counterclockwise, in fact, I want to make sure I hit this point a little bit. So I wonder if I can just type analog clock here. Perfect. Let's grab any of these. All right. So what I'm trying to say here is this is how an old analog clock worked, and the second hand is this one, and it would go tick, 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 and of course the hours and minutes would go that way. Well, this is clockwise. See, the numbers get bigger. This is clockwise, and then counterclockwise would be going 12, 11, 10, 9, 8, 7, 6. So defining the points, the winding in Godot, you'd want it always to go clockwise. So you're listing the points in 1, 2, 3, 4 order, not 4, 3, 2, 1 order. And I'm hoping I'm not being overly meticulous about this, but I have noticed talking to some younger people that the concept of an analog clock, some of them don't know what that is. And so when somebody uses a term like clockwise or counterclockwise, I get a shruggy shoulder. So hopefully this makes sense, and I'm hoping I didn't insult anybody by, you know, explaining this a little bit, because I think this is important to know. So that's where the terminology comes from. Okay, so we've defined the face. Now we need to define all the faces. So what I'm going to want to do here, and again, this is just, we could all define these in one big array, but I like defining these one at a time because it's less confusing. And if we look at our picture again, and so we're going to do the back face. The back face is the 4, 5, 6, 7. That'd be the two triangles there. But you kind of have to think about it backwards. So because you're looking at it from the front and not the back. Like, hopefully that made sense. We're looking at it from the back here, right? Because the way Godot defines back versus front, and you want the front of the cube to be sitting back here somewhere looking at that. So what we'd want to do here is we want to do 5, 4, 7. I know that appears from here like we're going counterclockwise, and we are. But because we're behind the face, we have to list it in the opposite direction. So 5, 4, 7 is counterclockwise from our point of view, but from the outside of the cube, it's clockwise. So 5, 4, 7. So let's go here and do 5, 4, 7. And then if we go to our picture again, and now the other face there would be 5, 7, 6. Again, I know it appears counterclockwise, but from the other end it's clockwise, so 5, 7, 6. Oops, 6. Okay. All right, so let's do the top face next. So, here's the top. This one's a bit easier because we're kind of looking at it from the outside anyway. So 4, 5, 1 is one of the triangles. 4, 5, 1. And then what's the other triangle here? 4, 1, 0. That's the bottom triangle. 4, 1, 0 listed in a clockwise fashion from the outside. 4, 1, 0. All right. Okay, so now we have to list the bottom face. So if we go here, and again, this drawing, because we'll be looking at it from the back, we have to list them in counterclockwise order for it to be correct when you're looking at it from, looking out, your eyeballs down here looking up. So what we'd want is 3, 2, 6. That's one of the triangles. 3, 2, 6. It's counterclockwise from our point of view, but from the outside's point of view, that would be clockwise. So 3, 2, 6. And then what do we want for the other triangle? The other triangle would be 3, 6, 7. Again, looks counterclockwise, but from the outside it's not. 3, 6, 7. Okay. And so we've got 4 to 6. We're getting there. Scoot down. So we got the left and the right faces to go. So let's do the left face. So let's look at our diagram here. So the left face, again, we're looking at it from the back according to this diagram, so we're going to have to list it in the opposite winding is what we would want. So the left face would be 4, 0, 3. That's one of the triangles. 4, 0, 3. So let's go here and define 4, 0, 3. And then the other triangle, oops, not that, I want a drawing again. 4, 3, 7 is the other triangle. 4, 3, 7 listed counterclockwise, but from the outside it'll be clockwise. 4, 3, 7. Okay, and 7 was right there, so awesome. And then we'll do the right face. And then we'll have all these faces defined. So the right face, if we go to our picture, luckily we're looking at it from the outside, so this will be easy. So 1, 5, 6, listed in a clockwise way. 1, 5, 6. So go to writer. 1, 5, 6, and let's look at the final triangle of this whole thing. So the final triangle is going to be 1, 6, 2, clockwise winding, 1, 6, 2. 1, 6, 2. Okay, so we have all of our faces defined now. So what we want to do is we're going to need to put them into one big thing so that we can send that in to this for each thing. So we want to kind of combine them together. And I don't know if this is necessarily the easiest way to do this. I didn't know because I'm still learning C#. There might be an easier way to do this, but I couldn't figure it out. So what I'm going to do is kind of the caveman way of just concatenating these all together into one big array. And if there's a different way to do this in C# that's more reasonable, please feel free to comment. So what we want is the final render. So final face vertices. Final faces vertices. So this is what we're actually going to render. And what we're going to have this be is an empty vector 3. And what's the size of it? Well, it's going to be front face dot length plus back face dot length plus top face dot length plus bottom face dot length plus left face dot length plus right face dot length. Okay. 1, 2, 3, 4, 5, 6. Okay, so we have an array here that's big enough to hold all these points. So now we have to copy in each of our faces we've defined. So what I found is if you use the beginning array that you're doing and you invoke the copy to on it, and you're saying, where am I copying it to? Well, I'm copying it to the final faces vertices. And you're telling it what index to start at. Well, since that array is empty, we haven't done anything with it, 0 is where we want to go. But we're going to have to keep track of where we are in this array, because now we've populated it with 6, because each of these are 6, right? 1, 2, 3, 4, 5, 6. So we have to keep track. This index can be 0 the first time through. Well, we're going to need to keep track of this. So why don't we just create a variable that does this? And we'll set it default to 0, and we'll use next index here. And then we'll kind of use our friend copy paste. So next index equals next index plus. So we should be able to copy this for all the rest of this. So front face, don't need the next index. So we want to do back face next. All right, then we want to do top face. Now, in this case, this next index plus, and then I'm doing, since these are all going to be 6 anyway, I could just do a plus 6 there and be done with it. But I just want to be overly verbose, because what if down the road we created something more complicated than this cube, where maybe different things we defined as a front face or a back face had more than just 6 or had less than just 6. So doing it this way at least allows us to have a variety of non-uniform faces. All right, so top face, we did back and top. So now we want to do bottom. And we'll do bottom here. And we got left and right to do, and we're done. Left face. left phase, and our friend right phase. Probably don't need the very last computation here, but we'll just be consistent. Okay, so hopefully this makes sense what I'm doing here. So in order to send to the surface tool, we need to send one large vector. I mean, I guess we don't need to necessarily do that. It depends how much we want to break this up. But the way we had been doing this is we were sending one big vector in of all of our vertices. So after I defined each of these sub-arrays, and I didn't have to do it in these sub-arrays. I could have just made this final faces vertices equal to just all these points defined in one big array. But I just wanted to be very verbose, because if you get the winding wrong, it's going to be easier to debug, at least I think so, if you have it broken down like this, because then you can kind of figure out where you're going wrong. So what this is doing is it's taking all of these vector 3 arrays, and it's making one big array out of them. So what we're doing here is we're making one big vector array that's the size of all of these other arrays combined. And then what we're doing is we're copying into this final faces vertices from all these sub things. Now this may not be the most efficient way to do it in C#. I was hoping there'd be like a add to end or something of an array, but I didn't see anything like that, so this is the closest I could find to that. So in the end, when this code is done here, this final faces vertices will have all of the points that we defined. So this for each, instead of it being in front face, we need it to be in the final faces vertices, because we want to render all of that. So in theory, we should be able to hit the play button here, and we should see our cube again, very close to what it looked like before we deleted it ourselves, the one that we made in the editor. So let's hit the play button. And if we scoot in, it has sides, so that's good. However, it was a bit smaller. The cube that we brought into Blender actually was I believe it was a 2 width cube, and ours that we made was a 1 width cube, the 0.5 to 0.5. So it looks smaller because it is smaller. So in order to make it to be the same as the one we brought in from Blender, let's just scale up our mesh. Let's scale up the mesh instance by 2, and that should give us what we want. So why don't we just go ahead and do a cube mesh instance dot set scale. Thought it was set scale. Oh, I think it's just scale. Yep. And we'll uniformly just scale it up by 2. So now when we run it, it should look just like what we had before. And it does. So we have our cube, so that's fantastic. And we've defined it programmatically inside C#. However, we don't have the collision object, and we don't have the signals. So we need to define that in code. And that's actually pretty easy, all things considered. So the way we would create the collision object in code, because before what we would do is have the cube, and we did it manually. We click on the cube, then click on this mesh thing, and we pick one of these options. But we're doing it in code, so we can't do that. I mean, we could, but that's not, since we don't know the mesh and editor time here, since we're doing it dynamically, it would be ridiculous to, like when you compute this, it's computing what? We don't have a mesh defined in the editor at this time. Only at runtime do we know what the shape of the mesh is. Again, I hope that makes sense. This would be pointless to run because the mesh has no shape as far as the editor is concerned right now. Only when the code runs does the mesh have any sort of value. However, this is really, really, really easy. So what you would do is do cube mesh instance, and let's just create a convex collision, and that's it. That's all you have to do. That's the same thing as picking one of those in the editor itself. It's the same thing as picking one of these. It's the same thing. So in code, fantastic. Now we have our mesh. It's attached. Now we can create the convex collision object, and fantastic. So now we have the collision object. But if you remember, we had certain events. We had certain signals that were attached to certain events, and we want to fire those off on this dynamically created collision object thing. So we need to grab. We created this convex collision object that's a child of the cube mesh instance, but we need to dynamically grab that so that we can. I don't think it returns it, does it? I don't think it does. We need to, returns a void. So we need to grab the child of the cube mesh instance, and we need to get a handle for that. So because this is the only child of the cube mesh instance right now, we can just grab the first child and we can assume that it's that collision object. So why don't we do this? We do a StaticBody, and what this would be is we would do the cube mesh instance, and what we would do is get the child. We would get the 0th child, which is a 0-based system, so that's the first child, and we have to cast it because we know it's a static body. So this is going to grab that. In this create convex collision, it created a child of this cube mesh instance. So what we're now doing is we're grabbing the first child. It's going to be the only child, but the first child of the cube mesh instance, which was created by this call. We know it's a static body, so we're putting a variable there so that we can do stuff with it. So what we want to do now is we want to assign those signals to those methods, but we want to do it programmatically. So if we go back to Godot, if I'm going to temporarily do this, I'm just doing this so we can see what those events are. All right, that's better. So if you remember, we cared about this input event, this mouse entered, and this mouse exited event. And so in code, we're going to want to do that. So why don't we account for these first? Let's just type these in the editor so we have them, and then so the first one's called event, or input event. Let's just so we have the name of these. So it was input event, and then it was mouse entered and mouse exited. Just doing this so that my horrible memory doesn't forget these things. All right, so let's undo what I just did here. And then let's remove this mesh. Clear. Okay, so we're back to where we were. I just did that so we could see what those signals were. So now we're back to where we have the cube with no static body below it, and it has no mesh because we're doing it ourselves. So if we go back to Godot, we want to the cube static body, which why don't we call that cube static body? That way it makes a bit more sense. So cube static body, and what we want to do is we want to connect a signal. And which signal do we want to connect? Well, let's move that. Let's do the input event first. Okay, and which object is going to capture this? Is going to be the callback for this? Well, it's going to be this script. This thing itself is going to be the thing. And then what's the name of the call what function is going to be this input event. Well, let's look here because it's been a while since I've done this. So this was the input event. So what we would want is this. We want this called on that signal. Okay. So what we would do is put that. However, that's not sufficient. We have to get like a pointer to the actual method. So what you would do is in, I believe it's a C# thing, you would just do name of, and you would put that thing around name of, and that's all you would have to do. So what this is saying is for the input event signal of the cubic static body, you're going to use this script and you're going to run the method on static body input event. So let's do 2 copies here. So the next one we're going to do is mouse exited. So MOUSTEXITED. All right, what's the name of the function? Let's look. Oops, they're right here, weren't they? All right, so it's called on static body mouse exited. So let's grab that. Go back up to where we were. There we go, up here. And we would change the name of the method it's calling to that. And I believe the mouse entered is called ENTRED. Oh, that's interesting. So writer actually knows. So I did it the hard way. I could just... All right. And let's make sure this event is mouse entered. And not monsk, mouse. Okay. So this should be all we need here because we've grabbed the static body after we ran the collision, the create convex collision. It added a child to the cube mesh instance. So what we're doing then is querying the cube mesh instance and saying, give me your first child. We're casting it to a static body because we know it's a static body. And then we're connecting the signals that we had connected before when we did it in the editor. So in theory, when we run this should be no different. Everything should be back to what we were used to running. So let's go back to Godot, hit the play button, and let's hope things work out well. All right, so if you remember, one of the things is when we entered and exited the cube with our mouse pointer, down here it would say cube entered, cube exited. Well, we entered the cube, we exited the cube, those two things work, and we clicked, it gave us a point. So the input one is working too. So we've now reconnected everything that we needed to do. And just to make sure everything's working as we hoped, let's go ahead, go back to the main node, again, the thing that has the script connected. Let's turn everything on just to make sure everything's working. Hit the play button. And this is now back to where we were. However, this cube we created ourselves. We went through and we defined all the points ourselves. And I know it doesn't seem like we actually did a lot there, but what we ended up doing here is we recreated what we did in the editor, and we actually created mesh data on the fly. And if you remember, the whole point of this video series is so that we can start manipulating the mesh data on the fly. Well, now we just created mesh data on the fly, so that's the first step, and then very soon we're going to manipulate this interactively while we're playing the game. And something that will be worth noting, while the game is running, if you go to your scene area here, and if you click on remote, you will see what the game is running, and it shows all those dynamic things that are running, like when you're creating stuff. So remember the cube mesh instance, and I said grab the first child because I know it's a static body. Well, that's that static body that create convex collision created. And then these two things here, the little pen there, those are immediate geometries. That's the wireframe and the normals. But those are created on the fly. So if you ever want to see what your game is doing when it's running, if you go to this remote, you can actually see what's happening as things are being created and deleted. And that's actually pretty powerful, because from here you can't, because this is just the static view of what you're setting up before you run the game. So I think we've accomplished a lot here. I know it may not seem like we have, but I think that this was necessary for us to know how to construct the geometry on the fly like this, because if our next goal here is to start, maybe grab this edge and subdivide it, or grab this face and extrude it, like, we need to know how to actually create geometry. And we created the geometry ourselves using the SurfaceTool. And this, creating the faces on the fly like we did here, as you could tell, it was a very kind of mundane thing to do, prone to errors if you don't know what you're doing. But I think we covered everything. I also explained the material property on how you could tell it what to cull. By default, it culls the back. That's why we have to make sure we use clockwise winding. So I feel like we've covered a great deal here, and I'm hoping it made sense. This was a little bit more thought and code intensive, and I'm hoping that I did a decent enough job and I was slow enough where it made sense. If something I explained didn't make sense, feel free to comment down below, and I will try to reply to your comment, or if it's that ambiguous as far as the answer, in the next video I will answer that question so that it makes sense. So thank you for watching the video, and I hope to see you soon. Take care.